Everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 133, clone graph. Given a reference of a node in a connected undirected graph, return deep copy clone of the graph. Each node in the graph contains a value and a list of its neighbors. Since we are solving it in Python, the definition for the node is given here. So we have a class node, and then self.value equals value. That's kind of the value of the node. And the self the neighbors is a list of neighbors that's connected to the existing node. So for simplicity, each node's value is the same as node's index, 1 indexed. So the index starts at 1 instead of starting with 0. For example, the first node with value equals 1, the second node with value equals 2, and so on. The graph is representing the test case using an adjacency list. So what is an adjacency list? Adjacency list is a way to represent the graph. It is a connection. It's a collection of unordered lists used to represent a finite graph. Each list describes the set of neighbors of a node in the graph. The given node will always be the first node, with value equals 1. You must return the copy of given nodes as a reference to the cloned graph. So it seems like the problem statement is a little bit confusing. So let's try to understand it through an example. So we have an original graph, so you can see it's a 1 indexed. So the node starting at 1. So 1, 2, 3, 4, and then they're connected together. So we want to create a deep copy, which means you cannot just return the same graph. That's a shallow copy. So this is not a solution. We want to create a deep copy. So the node should be the new, but the graph looks the same. So what does it mean for the graph looks the same? So the connections looks the same. Let's say in this case, for the pink ones, still new nodes. The nodes are cloned, but the graph is messed up because the relationship, let's say in the original graph, 1 is connected to 2, 2 is connected to 3. But in this new graph, the 1 is connected to 3, and then 1 is connected to 4, and 2 is connected to 4. 2 is not connected to 1 in this graph. So this is an incorrect solution. What we want is the cloned graph with new nodes, and then the same connections. The graph should look the same, the blue ones. So what is the adjacency list? Let's say here we have a list, and then each element in the list is also a list. So in this adjacency list, it indicates that, okay, there are 4 nodes in the graph. And then the first node, neighbors, is the second node, and then fourth node. So basically, for the first node, we look at the first element in this adjacency list, and then it contains 2 elements, 2 and 4, which indicates that for the first node, its neighbor is the second node, value equals 2, and the fourth node, value equals 4. So that's kind of the adjacency list representation. So in the second example, in this case, the adjacency list is empty. So it says, basically it indicates that it has 1 node that's starting at value 1, but it does not have any neighbors. Here, in example 3, this adjacency list is an empty list. So this is an empty graph. It does not contain any nodes. So what's the difference between these two? So example 2, so adjacency list is a list of empty list. So it indicates, okay, there is 1 node in the graph, but that node does not have any neighbor. In the example 3, adjacency list itself is just empty. So it does not have any nodes. So how to solve this one? So we can either solve it utilizing BFS or DFS. Basically, the idea is we want to create a hash map with or dictionary in Python with key indicates the node, the original node, and the value indicates the corresponding cloned nodes. That's the new node we created. And then we are trying to connect the nodes by assigning the neighbors. So I'm going to first solve it using the BFS iterative solution, and then I will show you how to solve it utilizing DFS iterative solution. So BFS iterative solution. So if not node, we just return. So first cover the edge case. And then for BFS, we utilize DQ from collections, import DQ. Q equals DQ. Node. So, well, Q. So the current node equals Q dot pop left. We mentioned we need a dictionary to keep track of the node. We call it mapping. So it maps the original nodes to the cloned node. So at the very beginning, it has the original node, the given node, and then also the cloned copy. So in that case, value equals not dot value. If and then for all the neighbors in current dot neighbors. If this neighbor not in the mapping, so which means this node has not been cloned. So in that case, we want to create a cloned copy. So we create a cloned copy, and then we add it to the mapping table. Indicates, okay, we have already cloned this node. We can actually combine these two lines into the same. So basically, we create a copy of this neighbor. We cloned this node, and then we also add it to the mapping dictionary. Basically, map the original node, the neighbor, to its corresponding cloned copy, and then we add this one to the queue. When we add to the queue, we add the original node because we need to track its children. So after we make a cloned copy, we can just assign the children or assign the neighbors. Sorry, neighbor is a more accurate terminology to describe the relationship between the node. So in this case, mapping.current. So the clone copy of the current node, the neighbors dot append mapping. So what does this line do? This line is just assign the relationship. Let's say indicate the neighbors or clone the node. So basically we created the new nodes, but just creating the new nodes is not sufficient. We also need to connect them into a graph. So basically this one is just to indicate the neighbors for the clone nodes. So we already cloned the current node. So the current node has a clone copy that's stored in the mapping dictionary. So we can retrieve that by utilizing mapping for get value for the corresponding key current. So basically here we retrieve the clone copy of current CURR node, and then we assign these neighbors this neighbor is the neighbor of the current node. So that's in the current neighbors. We just assign the clone copy. So basically, we indicate the neighbors for the cloned nodes. So from the original nodes, we already have their connections. Basically, we know their neighbors. For the clone copy, for the clone nodes, we just clone the node by creating the new nodes. But we haven't really assigned and indicate which node is the other node's neighbors. So we are just doing that utilizing this line. And then after that, we just return mapping node. So let's try to run this code. Okay, let's try to submit it. Yep, this solution works. So basically the idea is to utilizing BFS. So it's pretty standard BFS solution. We establish a queue, and then in each iteration, we are trying to pop one element from the top from the queue, and then we are just trying to find its neighbors, and then add a neighbor. If the neighbor does not exist, which means if the neighbor that hasn't been cloned, so then we create a clone copy of the neighbor, and then we also add a neighbor to the queue. We also establish the relationship by assigning the neighbors for the cloned nodes. So the key idea here is just to create a dictionary or hash map with the key indicates the original node and the value indicates the corresponding cloned nodes. So next, I'm going to solve it utilizing the DFS iterative solution. Okay, what's going on? Let me see here. Okay. So still edge case. Oh, my bad. Okay, let me solve it utilizing DFS iterative solution. So still edge case if. Okay, I know what went wrong. So if not node, just return. And then for the DFS, remember we utilize a stack. So here the stack should be the initial stack contains the node itself. And then we are still utilizing a dictionary mapping node equals with the value, the clone the copy of this node. And then we are trying to pop from the stack. Current node equals stack.pop. And then we check the neighbors. If the neighbor is not in the mapping table yet, which means the neighbor has not been cloned. So we need to first create a cloned copy, and then add to the mapping dictionary. And then we add this neighbor to the queue. Add the neighbor to the stack. After that, we just connect the neighbors. For the cloned copy. And in the end, we just return the clone copy of the node. Okay, so this is the end of my video. So if you like my video, please subscribe to my YouTube channel. Thank you.